Hope you are all fine, and I hope that you would understood all the previous videos, especially total internal reflection. We have discussed so many applications of total internal reflection. So this is also one of the effect of total internal reflection, that is refraction in glass slab. Okay, when the light is actually this is air medium and this is glass medium. Okay, this is glass. So we know that air is the rarer medium. Okay. This glass is the denser medium when compared to air. Okay. So we know that when the light enters from rarer medium to denser medium, the incident light, okay, it will be refracted towards the normal. This we all know. When it travels from rarer to denser, it will be towards the normal. Okay. Keep always this one in mind. And also when it travels from denser to rarer, it will be away from the normal. Okay. So let us consider one light source which is incident at an angle I. Angle I is incident. Okay. We all know that since it is traveling from rarer to denser, it will be refracted towards the normal. Okay. Let us consider it will be refracted towards the normal like this. Okay. Now this is the normal. Normal is always perpendicular to the surface. Yeah. Because here it is denser, again there is air. Okay. So this is rarer. So again when the light travels from denser to rarer medium, it is refracted away from the normal. Okay, it will be refracted away from the normal. So if this is the normal, let us take this as n and the next normal. In the medium, inner medium. So let us take this normal as n dash and it will be refracted away from the normal. It will be refracted away from the normal like this. Okay. So we can write it like this. Okay. Now, okay, when you take this incident light, in the incident light actual path it will be like this, right? The actual path of the incident light is this much, okay? But because of double refraction, okay, inga oru refract agudhu, appo again it is inga oru angle incident agudhu, again it is getting refracted. So because of that, it is deviating from the actual path through some distance. Or particular distance ka adu shift aayirukku illaya, inga vara vendiyadhu inda alavukku shift aayirukku. So this shift we are calling it as lateral displacement. Okay, this is called as lateral displacement. Clear? So here our aim is to find out the thickness of this, that is how much it is laterally shifted. Endha alavukku lateral adu displace aayirukku appdinu kandupidikiradha idhula nama pandra vera. Okay, so what is happening? It is incidenting at an angle I. It is again refracted. Since it is from rarer to denser, it is refracting towards the normal. Again when it comes to this surface, it is denser to rarer, so refracting away from the normal. Okay, so actually the path of the incident light is this one. So this is displaced this much, okay, laterally. So this is called as lateral displacement. Now our aim is to find out the how much the lateral displacement எதை depend பண்ணிருக்கு, எந்த அளவு அது வந்து அதோட thickness எப்படி இருக்கும், thickness not எந்த அளவுக்கு displace ஆயிருக்கு அப்படிங்கறத we are going to calculate it. So consider this as a glass slab. Okay, glass slab you can consider like this. Okay, this இந்த மாதிரி ஒரு slab இருக்கு, glass slab இருக்கு. Okay, so what is happening? A light is incident on the glass slab like this. Let us take the angle of incidence with respect to the normal as I. Okay, this one as A and this point where it is get refracted, that point we are calling it as B. From this point it is getting refracted through an angle R. Refracted angle is R. Okay, with respect to the normal. Now again when it comes here, let us take this point as C and it is refracted away from the normal and it ends here, that is D. Okay, so initially the path of the light is this only, but due to refraction in the glass slab it is going through this path. There is no change in direction. Keep it in mind. There is no change in direction. There is no change in direction, but displaced from its place. Adoda place inga, but adalelu displace aayirukku lateral. So it is called as lateral displacement. Okay, there are two refractions. Two refractions are there. One at point B and other at point C. Point B and point C la refraction nadakudhu illaya. So now we are going to find out how much it is laterally displaced. Okay, before that we name all the angles. If this angle is R, I can take this as gavanama gavinga. If this angle is R, இந்த angle I இல்லையா? So what about இந்த angle? This is also I. இப்படி இருக்கு ஒரு பாயிண்ட் இப்படி இருக்கு. So if this angle is I, this angle is also I. We all know that. அதேதான் இது. இந்த angle I அப்படின்னா this is all. நான் வந்து தப்பா வரைஞ்சிருக்கேன், but you have to draw it properly. Okay, this angle is also I. Okay, clear. So if the whole angle is I and this part is R, what about this angle? Okay, if this whole angle is I, adla na renda pirisite inda angle R abdina, what about this angle? This is definitely I minus R. So I have named it as I minus R. Okay, now come to this angle. Okay, for that we can take it like this, in this direction. Okay, so இப்படி இருக்கு இல்லையா, இப்படி வந்து இப்படி போகுது இல்லையா. So what about this angle? இந்த angle என்னவா இருக்கு? R. So definitely this angle is also R. So I am naming it as R. Okay. Then you take these 2 points. These two are parallel lines. Okay. These two are parallel lines. A ray is going like this. Okay. So this is idu or ray. Idhe angle la in the ray irukku. Seriya? So if this angle is I, in the angle I irundhuchna definitely this angle is also I. Idhe da irukku illaya. So in the angle I irukradhanaala definitely this angle is also I. Okay. Now let us take, so lateral displacement is nothing but the perpendicular distance between these two rays. Okay, in the rendu ray, actual ray ku ipo deviate aayirukka ray ku idaiyila irukra perpendicular distance da vandu and the lateral displacement. Okay, for that let us draw a perpendicular line. Okay, take it as take this point as E. Okay, let us take this point as E. Okay, so this angle is I. Let us take this point as E. Now we are going to find out the lateral displacement L. Okay. For that, let us consider. Okay. Let us consider the sine of this angle. Okay. So we have named everything. Just now we can take this triangle BCE. Okay. I have taken this triangle BCE. From that you find out what is sine IR. Okay. What is sine IR? Sine theta is equal to opposite side by hypotenuse. Here the opposite side is CE. That is nothing but L. CE means what? L. Okay, this is L. So this is L divided by what is the hypotenuse? It is BC. So I have written it as L by BC. Okay, L by BC. So from this, what is BC? L by sine IR. Take this is like this. The triangle is like this. This is B. This is C. This point I am taking it as F. Okay, the angle is R. So this one is, this depth is, we are taking it as T, thickness of the slab. This is thickness of the slab. Okay. So I can write cos R is equal to adjacent side by hypotenuse. Adjacent it is T. Hypotenuse it is BC. So T by BC. From this BC is equal to T by cos R. Okay. Take this as equation 2. When you see equation 1 and 2, both left hand sides are common. So we can equate the right hand side. That is L by sine I minus R is equal to T by cos R. I need what? Lateral displacement L. So L is equal to T into sine I minus R by cos R. Okay. So this is the lateral displacement. Okay. This is the lateral displacement of when it is refracted through a glass slab. Okay. T into sine I minus R by cos R. So this lateral displacement depends upon what are the factors. First it depends upon the thickness depend pannirukku that you want to write it. Okay, it depends upon it is the lateral displacement. First it depends upon the thickness of the slab. Okay, thickness of slab. Second one, it depends upon the angle of incidence kandipa depend pannirukku. Third, it depends upon the refractive index. Okay, depends upon the refractive index. That means what? இதோட refractive index எப்படி இருக்குதோ, இது rarer to denser. So இங்க refractive index high-ஆ இருக்கும். அதை பேஸ் பண்ணி தான் உங்களோட angle of refraction இருக்கும். அவே ஆகுறதோ towards ஆகுறதோ. So இது indirectly depends upon the what is that? Refraction. Okay, angle of refraction. Okay, so these are the factors the lateral displacement depends upon. So this question may be asked for 3 mark question. It is very easy. So once you understand this, it is very easy to calculate this. I hope you could understand all the effects of the total internal reflection. We have discussed so many effects. Please concentrate it and study. You can expect one question from the applications of total internal reflection. Thank you for watching.